Let us see how to distinguish aldehydes and ketones from the acid derivatives. So, the most reliable method to distinguish aldehydes and ketones from the acid derivatives is carbon 13. So, let us look at the chemical shift values of these functional groups. So, the aldehydes, the range is between 195 to 205, and the ketones 195 to 215, and the acids 170 to 185, the acid chloride 165 to 170, esters from 165 to 175, and amides 165 to 175. So the carbon 13 distinguishes acid derivatives from aldehydes and ketone. So there's a difference of 20 ppm, that is 195 and 170. So we can easily distinguish the aldehydes and ketones from the acid derivatives. So let us look at one example. This is a saturated keto acid, and in this case this carbonyl will appear at 179.1 because this is an acid, and this is a ketone. This will appear at 208.4. So you can easily distinguish whether the carbonyl is an acid or a ketone. So here are some examples where we can identify the aldehydes and ketones. So this is an aromatic aldehyde, that is vanillin. Here the aldehyde C double bond O will appear at 191, and this is a conjugated unsaturated aldehyde, the trans retinal. Here the carbonyl will appear at 190, and these are the ketones. Carvone, where the carbonyl ketone will appear at 199, and in this case this is a saturated ketone, that is raspberry ketone. The carbonyl will appear at 208, and this one is an acid. In the case of acid, the carbonyl will appear at 180, and the conjugated acid, this is shikimic acid, where the carbonyl appears at 160, and this is salicylic acid, the carbonyl will appear at 172, and in the case of the non-conjugated ibuprofen, the carbonyl will appear at 181, and in the case of acid chloride, so this is acetyl chloride, the carbonyl carbon appears at 170, and this conjugated unsaturated acid chloride, so this alkene will appear at 163, and the carbonyl will appear at 170. And in the case of anhydride, so this is an anhydride, so these two carbonyls will appear at 169 and 177, and in the case of unsaturated conjugated cyclic malic anhydride, so this carbonyl will appear at 164, and in the case of saturated cage tricyclic compound, this carbonyl will appear at 171, and in the case of esters, this is a conjugated methyl methacrylate, where the C double bond O will come at 167.9, and the ester of aromatic acid, this is benzocaine, where the carbonyl will appear at 165, and in the case of amides, this is a simple amide, dimethyl formamide, the carbonyl will appear at 167, and this is a tetrapeptide of alanine, where the four CO signals will appear at 168, 171, 171.8, and 173.8. This one, this one, this, and this. So all the aldehydes and ketones, the C double bond O group will appear between 191 and 208, and regardless of the structure, and the acid derivatives will fall between 164 and 184 parts per million. So let us look at these example where this alkyne on reaction with Hg plus 2 in the presence of acid catalyst, we get the product with the molecular formula C8H14O2. So what could be the product after, is it 1 or 2? So in the case of proton NMR, both shows a gem dimethyl. This is CME2 group, two CME2 groups, and one CH2. So we cannot differentiate this based on the proton NMR, and the C double bond O group of this compound appeared at 218. So that indicates the presence of a ketone. So this one is the product. So distinguishing aldehydes from ketones is simple by proton NMR. So we can differentiate the aldehydes from the ketones by the appearance of the aldehyde proton between 9 to 10 parts per million.